Dear learners, in this video we will learn about CNC Turning Programming. At the end of this video, learners will be able to know how to write CNC programming for facing, turning, grooving, tapering, threading and drilling operations. For us, we will consider simple facing operation initially. Let us consider a workpiece dimensions of 100 mm length and 50 mm diameter. Now in order to do simple facing operation, we need to give program of instructions to the CNC machine so that it will perform the operations. Now here I am taking O1001 is the program number. O indicates program number. I given as 1001 as the program number. G21 is the G code for input parameters in matrix. That means all the inputs whatever we are giving, the computer will consider in matrix, that is in mm. G98 indicates feed per minute and G28 U0 W0 indicates the home position. Now this is the home position where we need to change the tool. So now we call the tool the holder to home position. Now there again M06 is the automatic tool change for coding and automatic tool is T0101. Now at home position I can change any tool which I required. Now I given, because I am using a first tool for this operation, that I am considering as T0101, or otherwise here you can also mention which tool you wanted to use for this operation with full details, then automatically it will take from the home position. And M03 indicates the spindles forward and S2000 is the spindle speed in RPM. Now let us consider this is a sample which is 100 mm by 50 mm diameter, and the axis of this sample I consider as Z axis, and this face I am considering as X axis, where Z and X axis meet. This point is called 0, 0, where X is 0 and Z also 0. Now this is the initial cycle where I need to write for every program. Now from home position I need to call the tool to G00 rapid travel, X51 and Z51. The X51, this is the 50, and X51 indicates somewhere away from this sample, and Z1 indicates this point. So I called the tool near to the sample such that it can able to perform any operation. Now G01 indicates linear interpolation. That means from this point the tool need to move from X51 Z1 to, I need to give for 1 mm depth, 1 mm depth, that is Z minus 1, which indicates I am giving 1 mm depth towards Z direction, and F45 indicates the feed 45 mm per minute. And from here if I want to do facing operation, tool should come to the center of the Z axis. So now I need to write X is equal to 0 so that the tool will move from this position to till the Z axis where X is equal to 0. Then it need to go from here to here. That means again it is G00 rapid travel Z1. Where is Z1? On the same point, so it will go to that position. Then from here again it need to come to its initial position in order to give again another depth, that is X51. So in this way I need to complete several cycles in order to do 5 mm thickness of facing operation. So now in order to make a second cycle, I will consider Z is equal to -2 and G01 X0, G00 Z1, and then again it will come to initial position G00 X51. Then I will again increase the depth, Z is equal to -3 and X0 Z1 X51. Again I will increase the depth to z is equal to -4, x0, z1. Then it will go to again x51 initial position. Then again I will give final depth, that is z is equal to -5 and x0, z1, x51. Once this is over, the program is over, but the tool is at this position. But I need to send this tool to home position, so I need to write the again closing cycle, that is G28 U0 W0, sending the tool to home position, and then M05 indicates spindle stop and M30 indicates finishing operation and rewinding. So I need to write this two steps also at the end of the CNC programming for any operations. Now this program you need to execute. If you execute, this will be running here like this. Now the tool is coming here and giving the depth of cut, and again it is going back, and again it is coming to initial position, and again giving some more depth and going to the x is equal to 0. Like that it is repeating 5 times, such that it can able to do the facing operation for 5 cycles and perform 5 mm thickness of length of the workpiece will be removed. So in the same program you can also execute in CNC software. Let us also see how to execute this in CNC programming. Now you can copy this from here in this PPT. This PPT is available in the link provided in the comment section, or otherwise there is one more file also available in the comment section, and where you can see this notepad, one file is available. There all programs are written. So you can download this from the link provided in the below the video in the comment section. And if you open that, the first program whatever I discussed till now are written here. You copy this and Control C and minimize this, and you open CNC turning. So you open this CNC turning and this will be opening. So say OK. Then create a new part, say OK, and then you copy and paste this program, whatever you copied, you paste here. Then you need to give a blank size. So take a blank size. The blank size we consider as 100 mm length and the diameter as 50 mm. So start from this point, so say OK. Then go to mission, and we are writing this CNC programming for Fanuc OT type A. So different missions and different types will have different programming. So we are learning for the Fanuc type A mission. So G codes will be same, and only there is a parameters where the x and y z axis is changing from mission to mission. So here if you learn how to write the programming in one mission, and that other mission also we can easily write. Only thing is we need to see where is the work center, where is the mission center, and select it OK. Then you go to syntax in order to execute the program. So if any error is there in this syntax, it will show the error. Now there is no error, there is no warnings, so it is showing select the tool. So now this programming we are doing for facing operation. For facing operation I given the tool number T0101, so I need to select the tool, respect to tool in a tool number 1. So assign the tool. Now I want to assign the external turning tool, and go to this external turning tool, and there are series of turning tools are there, and I will select the first one. So say OK. Now once you select the tool and the tool will be appearing here, then say OK. Then now we can see the blank size, which is 100 mm length and 50 mm diameter, is clearly seen here. Now again, because we have taken the tool and assigned the tool, so you again perform the syntax, and it will also say OK, no error, no warnings. Now I want to run this program. So for that you just click on this the simulation, just start, and then it will start the operation. So if you start, then the tool is coming and 1 mm depth, it is going to the x0 y0, and again we are giving some more depth, and again it is going to z axis, and again it is coming back like that. It is repeating 5 times and performing and removing the material 5 mm depth in the length direction. So that is the simple facing operation. Once the facing operation is completed, the tool is going to home position. Okay, so this is how we need to perform the operations. Now let us go to the next program. So now simple facing operation is over. Now we will learn about how to write CNC programming for simple turning operation. Now let us consider another workpiece which is 100 mm diameter, 100 mm length and 50 mm diameter. We are taking a same sample size because you are learning initially, and if you take a same sample diameter, same sample size and perform the operations, it will be very easy for you to understand. Once after you understand at any diameter, at any length, you can able to write the programming. Now because I am writing this turning programming, so I will take the program number as 1002, and this initial cycle I wrote same like as it is last time for the program 1, and now again home position also. From home position I am calling the tool to x51z1 because I taken the same sample dimensions. Now here I need to perform a simple turning operation. Further the tool from this position where x51 z51, it need to give some depth. So if you give some depth 1 mm, that means I need to reduce the x dimension. X51 is there, the sample diameter is 50, so I need to reduce to the 48 or 49 so that it can able to come here. So now I want to give 2 mm depth of cut, so I mention here x48, that means 50 mm is the diameter. Now I am giving 48 is the diameter, so it is taking the depth of cut as 2 mm in this program. So now Z1, then you perform the operation. Now the tool is here and it need to travel from this place to where z is equal to -50. So I am giving G01, that is a linear interpolation, x48, z -50 and f50. S50 indicates the feed in mm per minute. So now again after tool comes here, it will remove the one layer of material on the workpiece and it need to go back to its original position. For that it will first come to x is equal to 50 and z -50, and it will go to rapid travel G00 x50 z1. So it will go to here. So then it is completed one cycle. In the similar manner I need to do several cycles till it get 45 mm diameter. So now for the second cycle I am giving x value as 46. That means if it is taking again 2 mm depth of cut, and again it is performing the cycle, and again for the last cut I am giving only 1 mm depth of cut, that is x45. So 46 to 45 it is only 1 mm depth of cut and z is equal to 1, and in this way it is going to perform the 3 cycles for getting the diameter value as 45. Now here again G01 x50 z -50, and it will go to home position, spindle stop, and then it will rewind. So now if you perform this operation, so it will be continuous like this. So depth of cut is given and the tool is moving till z value is -50, and again here again it is going back to its home position, its initial position, and again it is giving some more depth of cut is 46. Then again x value is 45, that means final depth of cut is given, and it is going till z value is -50, then going to x50 and z1, and then it is going to home position. So this way we can able to complete this simple turning operation. So this also we can perform, or if you copy and paste and work in CNC software, it will perform. So let us check this program. Whatever the program I written, it is here. You copy and copy and open CNC programming, and this already another program is there. You control A and delete, so this program will go and paste whatever the program you have copied for the second programming. So the now 01002 is the second programming. Now blank size is same, and mission type we already selected, and the tool also same. So you just syntax, so it will execute the program. So now tool also we have taken the same tool, whichever the turning tool, the same turning tool is sufficient for making the turning operation. So just you on the mission run the program, so it will run the program till z value become -50. Again it will go back and giving x is equal to 46, and it will go till z -50. Again finally x value is 45, and it will go till z -50, and it will go to its initial position, and then it will go to home position. This way this program will continue. Now let us go to the next program, that is writing programming for grooving operation. So now this is the tool, this is the workpiece I am considering. Here I wanted to make this groove, this type of groove. So I want to consider in this the place, so where this length is 10 mm, and this is 5 mm this is another 5 mm. This distance is diameter is 30, and this diameter is 40. We know the diameter of the sample is 50. So now initial cycle, this is same for all the programs, so this I have copied, and then G00 and X51 and Z -68. Now the tool is here, that tool I am calling here. So I am calling here, and I am mentioning Z value as -68. Generally this is 60, and here it is 70. If I mention 70, what will happen? So now I have taken this right grooving tool, and I am taking this right groove or right edge as a reference. So if you take this as a reference, the advantage is it can able to perform accurately at the end of the cycle to 60. So that is why I have taken this edge as a reference. When I taken this edge as a reference, now Z value I am giving Z is equal to -68, because this width of this tool, grooving tool, is 2 mm. Sorry, this width of this grooving tool is 2 mm. So if I give Z value -68, so it will perform the grooving operation. Then if you take the dimension from here to here, it will be exactly 70, because I am also considering the width of the tool. So that is why Z value I am considering as Z -68. From there this cycle will start, grooving cycle will start, and for grooving cycle the G code is G75 and R1. R1 indicates it's the allowance for each the depth of cut. So now it is cutting here. So for every cut it need to make some allowances, some gap for the each cycle, so that it will not the tool will not break. So that means it will come and it will perform, and again it will go back, it will come and perform, again it will go back. So like that for every cycle it will till it will get the required diameter of the workpiece it will do. But continuously if it is doing, the tip will break. So it will do operation, again it will take 1 mm back, that is nothing but the retraction, that is 1 mm. So again G75 and X40 indicates till the groove, the depth becomes 40 mm diameter, so it will perform the grooving operation. So when it is making the grooving operation depth, this length of the groove also very important. If you want to make the groove depth as a 10 mm the depth, we need to take this groove length also 10 mm. So now when you are selecting the tool, we need to select the tool in such a way that the tool width will be only 2 mm and the length will be minimum 10 mm, because we need to make this diameter which is 30. So now Z -45, so that this indicates now at the grooving operation starts from with this reference when the z value is minus 68 till it becomes minus 65. That means exactly here. So then P200 indicates the depth of cut for each cycle, that is 200 microns, and Q is the width of cut, that is 1000 microns, that is nothing but 1 mm, and F220 it indicates the feed per minute, mm per minute. So here I given feed per minute is less because the grooving operation need to be done and with less feed rate. And once this is over, now it need to go to, the tool need to go to X51. That means it need to come back here, and again it need to go to home position. So that means when it comes perform this last operation, it need to go back and it need to go to the home position, because I need to continue the other cycle for this groove operation. Again I need to write another cycle here, G75 R1 G75 X30. Here the diameter is 30 and Z minus 60 till Z becomes the minus 60. That means here it will perform the operation, and I taken same depth of cut and the feed and even the width of the cut also. Then it will go to G00 X51. That means it will go here, and then it will go to G28 U0 W0, the home position. So if you don't mention this value and if you directly mention home position, the tool will go like this. So at that time the tool will break. So that is why we must take the tool out from the groove, and then we need to send to home position, and then we need to off the spindle, and we need to rewind. So this program also we can perform in CNC turning software, and if you perform, it will be running like this. So it is making the grooving operation here, and again second cycle and third cycle, so like that. So slowly it is making, and then when it comes to second operation, it is taking 2 mm depth at a time, because I given the programming in such a way that it is taking 2 mm for a first depth, and then again 1 mm for the second depth. So once the 5 cycles are over at the second groove, it will go back and it will go to the home position. The similar way you can just copy and paste this program in program 3. So this program 3 is missing here, so just I will copy from here only. So I will just copy and I will copy and paste here. So again that way also you can copy. So again I am copying here, and you wanted to perform another operation. So if you go to new, again you need to select the blank size, everything. So I am avoiding going to the new program. So just copy pasting, and now I need to change the tool. So without changing the tool, it will not perform the operation. So without changing the tool, just let me go to the syntax, and it is executing, and it is saying 0 error and 0 warnings, but it is saying invalid tool for grooving operation, because we have taken a grooving operation program and we given a turning operation tool. So invalid tool for grooving operation. So we need to change the tool, otherwise it will not perform the operation. So say OK. So and again it is giving the warning. So say OK and go to tool, and here the external turning tool is there. You click on this and assign tool. Now you need to assign external grooving operation. So go to external grooving operation, and we need to take a external grooving tool of 2 mm width, and again we need to take a right hand tool. So this tool we need to take. So say OK. Then once if you select OK, it is asking whether you wanted to take tool reference edge as a left or right. So we return the program the tool edge reference as right. So select the right and say OK, and then say OK, and then you again, because we have changed the tool, you do syntax again, and it will execute the program. So now we can able to see the blank here, and just you run the program. So now the tool is coming and it is performing the operation. So again how many cycles? 3 cycles for the first depth and 5 cycles for the second depth again. So again it is operating. See, so second groove is running. So because we have taken exactly 10 mm is the length of the groove, it is just coming and touching here without measuring the edge. So now this program also over. Now let us go to the next program, that is taper turning operation. In taper turning operation there are two types of taper turning operations are there, but let us first try to understand this, then we can go to in details in the next video. So now let us write the initial cycles, and spindle I am taking as 300. You can change it to 2000 also, there is no problem. And I have taken less spindle speed. Then now I need to write taper turning operation. For that I need to first use this G code G90. Before that I need to give Z value as 0. That means before you write this cycle G90 code, G00 X51 Z0. This is also very important because the turning will takes place at this position. So if you write here Z value as -20, so from -20 to -50 only turning operation will takes place, and here the no tapering will takes place. So that is why you need to make Z is equal to 0, and then G90 is the taper turning cycle. So X50, that means another diameter, the major diameter is only 50, and the depth up to which we need to make the tapering is called Z is equal to -50. That means this is the tapering we need to make it. And R0, that means initially when you are making the tapering, it is not directly making the tapering. So first it will give some depth and it will make the turning operation. Again it will give some more depth and it will make the tapering operation. So here initially, for initial cut, R is equal to 0, I am giving F is equal to feed rate, that is 30 mm per revolution. Now this is the axis. Now I am considering as this is as a 35 mm diameter, and here I need to make the tapering operation. So now here in tapering operation I need to mention R value every time, so that it will go and it will perform the operation till R value becomes -7.5. So here this diameter I am considering as 35 mm. So this is a 50 minus 35 is called 15 mm. The 15 mm on both the sides, so one side it becomes the 7.5. so this is the R value. So R value becomes 7.5. so this 7.5, instead of giving at a time 7.5, so I will slowly remove 1 mm for depth of cut. So here I will mention X50 R minus 1 and X50 R minus 2, X50 R minus 3, X50 R minus 4, and this way I will continue up to X50 R minus 7, and at finishing cycle I will give only 0.5 mm depth of cut, X50 R minus 7.5. So then after that it will go to home position, and then it will stop the spindle. So now let us run this program in software. So if you run this program, so see here initial I given R is equal to 0, so it is not taking any depth, and for second cycle it is taking 1 mm, and third cycle it is taking so like that it is keep on performing the tapering operation until we get the required number of diameter of the workpiece on the other side. So it is performing these cycles for several times. So here I given only the 8 cycles, so it is performing the operations for 8 times. So this way we can continue, and the tapering operation, this tapering operation let us see in our software also. So you can just minimize this and then go to this WordPad and copy this program, copy, and go to this here and copy and paste your program here. So now this is the operation you are considering. Which operation? This is the taper turning operation. So now you need to take the tool. So if you go to syntax, it will not show any warning and but only thing is the tool we need to change, because earlier which tool, grooving tool is there, so go to tool, and now because for turning operation we need to give a external turning taper turning tool, and then select it, say OK. Then you go to syntax again and execute the program. So this way it is continuing. So now till R value becomes -7, it will perform the operations. So this way we can do this turning operation, taper turning operation also. So now we will go to the next operation. So this operation, next operation is external threading operation. For external threading operation, we need to carefully observe the cycles, the G code. Here we use G76 G code for external threading operation. So the cycle will go like this: G76 PQR and G76 XZPQF. So here each and every parameter indicates one threading value. So if you consider first P02 B1560. So here we will mention 6 parameters, 6 values here, but first 2 digits indicates number of turns to call the finishing cycle. So once we do this threading operation, it is not possible to make in one pass. So we need to make several cycles such that threads will be formed smoothly. So here 02 indicates is the number of times to call the finishing cycle. So once the full threads are formed, we need to perform this operation 2 more time extra, such that we will get the finishing cycle, the teeth very smoothly. And the next 2 digits indicates it is the pull out angle in degrees. Now for every cycle, when the tool is coming and performing and going, so when it is going, how it need to be moved. So the tool will come here and it will perform, and it need to go with some angle. That angle is called as pull out angle. That pull out angle, if it is 0, it will exhaust slightly, it will come like this. If it is 90, it will go like this, so that at that time the threads will break. So this pull out angle is 15 degrees, and this pull out angle must be less than the angle of threads. So if the angle of threads is 60, and this should be less than that. So then again C is nothing but the last 2 digits. This is the thread angle, these are in degrees, that is 60. This is the thread angle, this usually in 60, sometimes it may be 56, or sometimes it may go to 65. So whatever the angle here, so that we need to mention here. So that is the first parameter P indicates here. And the next one is Q. Q indicates here is the depth of cut in microns. So here in microns, 200 or 300 when you mention, that is not in mm, it is in microns. So 500 microns means it is 0.5 mm, and 1000 microns means it is 1 mm. And R indicates the finishing allowance. So once after every cycle, it need to give some allowance. For finishing allowance, the R indicates, and it is in mm. And X is the minor diameter. This is the minor diameter of the threads. And then Z is the thread length, and how much threads, how much depth, up to what depth of Z value need to be perform this threading operation. That is we are going to mention here. And here again P is there, and this P indicates thread height. So here this is the thread height. So this thread height we need to mention in microns. That may be 200 microns. 200 microns means it is 2 mm height thread. So that need to be mentioned in microns. And depth of first cut. So here the Q indicates the depth of first cut. When you want to make the threading operation, the first cut is more important because it is going to form it is going to form the a pattern for the upcoming threads. So the first cut is more important. So if it should be little more than the depth of cut we are mentioning for the second cycles. So here the depth of first cut we are mentioning in microns, because this also it is taking separately because the depth of first cut is more important in order to make the pattern of the threads. And then F indicates the pitch of the thread. So pitch of the thread, here if you see, this is the pitch of the thread. This pitch of the thread may be sometimes 2 mm or 3 mm, that we need to mention here. Here F is not the feed, it is only pitch of the thread. So that we need to remember compare with other cycles. Now if you go to the external threading, so here I want to make threading here from this here to here. So here the 50 mm depth I wanted to make the threads with the same diameter. The diameter is 50 mm, and here I want to minor diameter I am taking as 45. So now initial cycle we will, as usually we will write here, and then we will start the, before we start it, so from where we need to start the threading, that number we need to mention, that is X50 and Z0. Then G76 P03 I mentioned, that means finishing cycle I need to perform in 3 times, and 15 is the pull out angle, and 60 is the thread angle, and Q is the depth of cut. It is in 20 microns, that means it is 0.02 mm, and R is the allowance that I am mentioning as 0.15, and G76 X45 till the X become minor diameter is 45, and Z is equal to minus 50, and a P1840, that means 1.84 mm is the thread's height. So I mentioned here, and the Q 30 microns, that means initial cycle depth I mentioned as 30 mm, and remain after cycle it will be take as 20 microns only, F 30, and this is the pitch of the thread. Then it will go to X50 and home position, and it will stop the spindle. So this way we will perform the threading operation. So if you perform the threading operation, see here it is the same thing. If you copy and paste in the software, it will perform this. So this is called external threading operation. So we will just and here only the important thing is we need to properly select the thread tool for the threading operation. So if you select the tool which will not perform the value, this is P the 1840, so it will be that means the thread height it will not take the, so that means whatever the program we are writing, the tool also we need to select in such a way that it can able to perform this thread height. So that is the only important thing here. So here now let me execute this program 5 in a very short program, but it will take a lot of time for doing the operation. So I will just go and I am just removing this program and copy paste, and blank everything is set already. Go to syntax, and 0 error, 0 warnings here, but here it is saying invalid tool for threading operation, so I will say okay, but change the tool. So go to external turning tool is there, select here and assign the tool, and now threading tool I need to assign. So external threading tool I will select here, external threading. So go to external threading, and there are several threads are there, and whichever the thread you select that need to be able to do the threads which you want actually. So here I have taken which can able to make the thread depth as 3 mm. So I need only thread angle thread height as 1.84 mm. So this tool is sufficient for performing the threading operation. So I will select this, say OK. Then afterwards again I will go to syntax because I have changed the tool. Then I will run the program. So now you see it is performing the tool. It's very fast, and you can even reduce the speed of the tool, and we can see. But now we need to see other programs, so we will go a little faster. So now till the diameter, minor diameter will become 45 mm, this operation will continue, and once it becomes 45 mm, so it is also giving a pattern of the threads, and then it is doing the, so when it becomes diameter becomes 45, so it will stop the operation. So now we can able to see the threads also once the operation is completed. So similarly we will complete, we will do other operation. So external threading is over. Now drilling operation. So drilling operation, here I want to make a drilling here. So for this I will write the program same as it is like earlier, and I will call the tool to x0z1. So now the tool is here when I write the program here, and it need to come to z axis, at the z axis where x is equal to 0. So now I given x is equal to 0, z1, so that means the tool is here, and now it need to perform the drilling operation. So now the drilling cycle will go like this. So G74 is the drilling cycle G code, and R1 is the retraction, and whatever we mention in grooving operation, same retraction, and then G74 x0. So x0, that means where x is 0, there it need to perform the drilling operation, and till z becomes -50, and Q 500 indicates the depth of cut in 500 microns, and F is the feed rate. And again after it perform the drilling operation, and it need to come out from here, so that means z value become 1. Then it will go to its initial position G00 x50, and it will go to home position and spindle speed. So here the important thing is we need to select proper drilling the tool. So here if suppose if you want to make a drilling size of 20 mm, you need to select a drill bit size of 20 mm. So if you want to make 23.5, so you need to select the respective drill bit. So based on the availability of the drill bits there. So here that is the only thing. Let us try to execute there, and instead of here also we can just drilling operation. So here let us try to execute this program in software. So let us take this drilling operation. So here you copy paste, and now we need to change the tool. So here again it is showing the warning, it is not shown, but we need to change the tool. It is the drilling tool. So go to assign tool and go to drill, and we need to select the drill tool diameter of 23.5 I wanted to make drill. So say OK and say OK, then you go to syntax, and it will show the blank and run the drilling. So now you see it is just performing the drilling operation, and again it is going to its home position, as simple as it. So again now for example I wanted to make another operation, internal threading operation. Now here in this drill I want to make some internal threading operation. So now what to do? So if suppose if you want to make internal threading operation, first of all we need to do drilling operation, because without drilling operation we can't make the internal threading operation. So here we need to combine drilling operation as well as internal threading operation. So for that we will just write 1006 program, and then we will write the drilling operation whatever we have done till now. So the drilling operation we will write, and again we in continuation of the drilling operation we need to write the internal threading operation. For internal threading operation, we need to write another program. Now here you see, now G00, now here we have made, let us say that in this, when you perform this, we are performing the drilling operation. Now this drill depth I am taking as 23.5. So I wanted to make the threads here. So for that reason, I just take the tool, threading tool, to X22 Z1, and then G76 P06 and 00. So here the thread cycle, whatever we have discussed earlier, the same thread cycles for internal threading is also it will applicable. So G76 P06 is nothing but a finishing cycle 6 times, 00 is nothing but the pull out angle is 0, and 60 is the thread angle, and Q is the depth of cut, and R is the allowance, and X23 is the minor diameter, and Z minus 40. So at minus 40 I am performing the thread operations, and R0, P is 900, and Q 367, and the pitch length is 1.5 mm. So again it is closing the G01 and X22, that means it is going back there, and again it is performing the it is going to home position, and then it is spindle is stopped. So this way we can able to perform the internal threading of. So I have done the drilling operation, then now I am doing the internal threading operation. So this is how we can able to do threading operation. So in the then let us go to the next part. So now till now we have done around 6 different programs, 6 or 7 different operations we have learned, and let us make this let us write CNC programming for the given object. So now here you consider another part where you need to write the CNC programming to manufacture this component, and take the blank size of 50 diameter and 100 mm length. So we have taken the same dimensions because it will be more useful for you and it will be easy for you. So now let us try to write the CNC programming for this component. So here if you observe carefully, when you now till now on one blank or one workpiece we performed only one single operation. Now let us see if you want to perform several operations, how to perform these several operations, that we are going to learn in this the parts. So we have taken one sample, part 1. So here if you observe, so this is also 100 by 50 mm diameter sample. So here I need to perform first several operations. Let us say we will first perform up to 50 mm, this is 50 mm. So here 5 mm the facing operation I will perform, then I will perform up to it becomes the 45 mm diameter, I will perform the turning operation. Then I can perform a grooving operation in order to make the grooving operation, and then I will perform the threading operation and then drilling operation. So here internal drilling is not mentioned here, and only the external drillings are mentioned. So let us try to write CNC programming for this component. So first of all, whenever you wanted to write the CNC programming for several operations on the same component, we first need to identify what are the sequence of operations we need to perform on this component. The first we need to perform a facing operation, then we need to perform a turning operation, then grooving and threading and drilling. So this is the sequence of operation we need to perform, that we need to know well before you start the programming. Then you need to know what are the tools required for these operations. The first one is turning tool is required in order to perform facing and turning operations. Then in order to make a grooving operation we need to know external grooving operation. Then when you want to make a threading operation, so thread tool is required and drill. So this is the sequence of tools we need to give also. So we will give first tool as a turning tool, second tool as a external grooving tool, and a threading tool and drilling tool. So this sequence also we should remember, and the tool sequence also we need to remember. So now let us try to write the program. So now whatever the program we have written for first CNC program for facing operation, same program we can execute for this object also. So that is why what I suggest, whatever we have written the programs, so that programs we are going to copy in one single notepad. So now I think you can able to see this program. So I copied all the programs here. So now I wrote a single, now I am increasing the font size so that you can able to see properly. So now this is the first program. So program number I am giving 1001. So this is the component I wanted to make actually. So this is the component I wanted to make, and this is the program. So now I written the program number. For making this entire component I need to write only one program. So the program number is, let us say, 1001. And then this program I copied. This is nothing but whatever the initial program we have written, the same program, but the same values are given here also. So for facing operation 5 mm only I will remove the material. So the facing, this is the facing operation too. So same program I copied. But if you observe that at the end of this program, so here we are actually G00X51. So that means this is here, this point is here, that means the tool is here now, and it is going to home position. So from there it is going to home position. So once after it going to home position, in order to make the next operation, so if any other tool is required, we can change the tool. Otherwise we need not to change the we need not to stop the spindle, we need not to rewind the spindle. So this we need to remove because we are not stopping the program. So remove this. So here first we are making a turning operation, and we are continuing with the same tool actually. So we are continuing with the same tool. So you need not to send to home position also. Home position we need to send whenever we need to change the tool. So here we are not changing for the facing turning operation, so you remove this also. Now this is the second program which we have written for turning operation, external turning operation. So here we don't require another number for another program, because same we are combining all these programs, all these operations on the same component. So this is not required. Again, this metrics and all we already given into this program. So we are continuing with the same tool. So till here we are removing. Okay, spindle speed also need not to, because same spindle speed you wanted to continue, so you remove till here. So now I am combining this. So let us, there is a gap, but let it be having some little gap, there is no problem. So now I am combining these two. Now it is at GX51. So now I am taking this to Z1. Then I am giving the depth of cut of 48, and I am continuing with the same with the turning operation. So this turning operation will continue till here. It will make the facing operation. With the same tool it will continue the turning operation over here. So it will continue. So this is the second program which we have written. Again, after completing the second program, that means the turning operation, so again it is going to home position. So we need to go to the home position, because the next operation is a grooving operation. So this, to make the grooving operation, we need to change the tool. So let it go to the home position, but we need not to stop the spindle, and we need not to rewind it. So we will remove these two. Again, now for the third program we have written for grooving operation. So now we need not to give another the program number. So we will remove till here. So it is already in the home position. This also we will remove till here. Now here it is at home position. From home position it is asking automatic tool change. Automatic tool change T0101. So already T0101 we given, that is for turning operation. So now, because we need to perform a grooving operation here, so I need to change the tool. The tool number also should be different. So now I am assigning the tool number 2 for the grooving operation. So now for tool number 2, T02 I am mentioning. So that means the second tool is the grooving tool. So that we need to remember. So again, spindle speed is 600 for this once after you take this tool, and again it is going to this position. So now this I have written same as it is with the same dimension. I am performing this grooving operation, so I need not to change anything here. So again here, once after it is completed, it is going to home position, and I need not to stop the spindle, so I will just remove this. So next, fourth program is threading operation. Sorry, it is a taper turning operation, so we are not doing any taper turning operation, fourth operation. So I just remove this fourth operation. And the fifth operation is, it is G0. So fifth operation is threading operation. So for threading operation, sorry, this is the threading operation. So I need to make threading operation here. So here I will keep this. So now I need not to write the program number. Home position already it is there. So till here I will remove. So now for third tool is threading tool. So now again it is asking the tool number, that is T0101 is there. I will make the tool number as T0303, so which is the tool number 3, and then the threading cycle will continue. Now when you make the threading cycle, here I need to change some parameters. Now here you see external threading I made, the minor diameter I given as 45 here earlier, but now the minor diameter, it is major diameter is 45, but the minor diameter I will just mention as 43. So here you mention the minor diameter as 43 because 2 mm I am giving, and only the thread height is only 1.84 mm. Remaining everything I will keep as it is because the diameter has been changed now, external diameter, because of a turning operation. So I will remaining things I will keep as it is. Again now it will spindle stop, this are not required. So next operation is sixth operation, that is a drilling operation. So drilling operation, so I need not write another programming number. So home position already it is there, so I will just remove till here. Now again drilling operation, till this threading operation I given tool number 3. So for drilling operation I am giving tool number the 4. So T0404. So and then I will perform the drilling operation as usually. So once after this is over, what is happening? So again I need to send to home position, I need to stop the spindle, I need to rewind the program. So that is how I need to perform. So this is how I perform, and this last internal threading operation not required, so I will just remove it. Okay, so now this is the program. Now I can, I can easily execute this program in the software. So I will just, what I will do, I will copy entire program from this notepad, copy and minimize. This also I will minimize. Go to the software. So now you remove this program. So Control A, delete, and then copy paste. So now this is only a single program, but only thing is I break the different operations, but I also break the different tools. Now you go to blank size. Blank size already 100 by 50 is there. So the mission type is already type A is there. So same thing you keep. Go to syntax. When you go to syntax, because we have given 4 different tools, so here the tool numbers are given 1, 2, 3, 4, 4 up to 4. Now the first tool which we have discussed here is, so now this is more important. Now the sequence of operations are facing operation, turning operation, grooving, threading and drilling. So like that we already written the program. So now the tools used is for turning and facing, turning tool, and grooving tool, threading tool, and for this drilling tool. So these 4 different tools also we need to mention in the software, then only it will perform the operation. Now first tool is the turning tool. So go to external turning. So external turning, take the first tool and select it OK, and the second tool is grooving tool, assign it. So go to grooving operation, external grooving operation. So external grooving, and we have taken a 2 mm width and depth is 100 mm, 10 mm depth. So select this tool and take as right at the edge as a reference. And then the third tool is, it is a threading tool. So go to threading tool, external threading. So external threading tool. So go to external thread and then here the first one only we have taken last time, so take same the external threading tool, and the next one is the drilling tool. Go to assign tool, so drilling, twist drill, go to twist drill, and now I wanted to make the drill diameter as, let us say, the 23.5, so or otherwise I will make 20.5, so save OK. So now these are I assign the tool, so save OK, save OK. So now again you do syntax because we have selected the tool. Now the blank will be visible. Now you run the program. So if you run the program, see first facing operation. First it is performing the facing operation for 5 cycles, then it will perform, so now 5th cycle is completing. Now we can also see which cycle is performing by clicking the arrow here. So now wherever it is going, so it is showing in the black color in this tab. We can observe in the tab with the black color. So here now the tool is at G01 x46 Z minus 50. Then it will go to G01 x50 minus 50, again G01 x45 Z minus 50. So it is performing the turning operation. Now the turning operation is over. Now it has been stopped here. M06 automatic tools change T0202. We already assigned the tool, but we need to say whether it need to be start or it need to wait. Because it need to be start, we need to click on this next tool. So if you click on this next tool, it will come and it will perform the operation. So now, so I given some wrong values, so that is why it is just taking here. So I think I given the wrong programming. So I think these values I given till here only. So that is why it is taking the groove here at minus 60, not at minus 70. So that is why it is performing the grooving operation here. I think that values I need to change. Now I need to make the threading operation here. So now again I need to say go to the next tool. So then now it is threading operation it is doing. So it will do the threading operation in this 50 up to 50. So once the threading operation is done till the minor diameter becomes 43, so it will continue the programming. So once after that, it will stop the program. So now threads are made here. Then go to next tool. Next operation is the drilling operation. So the drilling tool is coming and it is performing the drilling operation and going. So this is how we can able to, now it is stopped and it went to home position and spindle stop, and it will also remind for the next program. So that is how we can write the CNC programming for combining all the operations on one cycle. So this way, this is one sample part which we have made. Similarly, in the coming video, we will see how we need to write the CNC programming for the sample any other part we give. So thank you for your patient hearing.